The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Hello everyone and welcome to the .NET Core podcast, an award-winning podcast where we reach into the core of the .NET technology stack and, with the help of the .NET community, present you with the information that you need in order to grok the many moving parts of one of the biggest cross-platform multi-application frameworks on the planet. I am your host, Jamie GaProgMan Taylor. In this episode, I talked with Stephen Cleary about his comparers library and how comparison and equality of objects in your codebase mean different things to different people. For instance, one block of code may view equality as two different object instances with the same ID field, and a different block of code may view equality as a combination of other properties being equal. It's all different for different people, for different consumers, right? We also talk about the importance of unit testing in the comparers library, and how writing these unit tests has sort of unearthed some interesting corner cases in the .NET BCL. Along the way, we discuss our opinions and guesswork regarding a potential corner case in the .NET BCL, but please do remember that neither Stephen nor myself actually work for Microsoft, or indeed were involved in writing the original BCL. As such, our opinions and guesswork are just that, guesswork and opinions. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. So, Stephen, welcome to the show. It's wonderful to be connected with you.
It's great to be here.
Thank you very much. Thank you very much. Now, we are going to talk about comparers and the spaceship operator a little bit today. But I thought, before we did that, would you mind giving us a bit of an elevator pitch to Stephen and like some of the work that you've done, or like the open source libraries and stuff that you've been part of, just so the listeners get a flavor for, who is Stephen and what does he do?
Yeah, sure. So my name is Stephen Cleary. I live in northern Michigan in the U.S., so quite a distance from you. And I have been doing C# for quite a while now. Most of what I'm known for is work with async and await or other asynchronous things. And I also have a few other open source libraries that are not really related to async and await, one of which is the comparers library that we're talking about today. I have a few others as well, but my async EX library is probably the most well-known of the ones that I've done.
Cool, okay. So I don't think I've come across the async EX library myself. So I guess before we start talking about comparers and stuff, is that different to async await in C# and .NET, or was it like before, back when we had the parallel compute libraries? How does that all work?
So async EX, what most people use it for is actually asynchronous coordination primitives. So these days you do have Semaphore Slim, which has a wait async on it, and you can use that as an asynchronous semaphore or semaphore, however you say that, or a mutex, mutual exclusion object. And there's also some other ones in there. So there's some asynchronous collections. There's a whole bunch of other coordination primitives like monitors, and I even do some condition variables, which I have found occasionally useful, especially when implementing collections. So this was all, again, before channels, but a lot of people still find those types useful even these days.
Yeah, I like it. It's always worth having more tools in the toolbox than you need, right? Because then you can pick not necessarily the right one, but the most correct one, right?
It's a good way of putting it, yes. And my library, if you look at something like system threading channels, it's extremely efficient, and it's a fantastic library. That's what I steer people towards these days. But the async EX library is really geared more around correctness than efficiency and maintainability. So there's not a whole lot of interlocked variables or anything really tricky like that with like lock-free solutions. I use a much more basic and easier to maintain kind of approach with my own library because I have to maintain it.
Sure. And I think there's definitely something in that. I feel like there's a lot of people who produce very terse, almost laconic code that no one knows how to read it or what it does. But whatever it does it very fast and uses hardly any memory. But no one knows what it does, right?
Yes. I recently did a video series on YouTube on TCP/IP protocol design, which is something that I learned many years ago and it's something you hardly ever use, but I wanted to do a video series on it because .NET had come out with pipelines and things like that. And so I wanted to use pipelines and channels and see what it looked like to build a TCP/IP application using modern techniques. And it was fun, but some of that code was a little confusing. You get into the span constraints and stuff like that. And I'd never really used, what were they, like read-only ref structs and things like that I'd never even used before, But it was fun.
Well, I mean, rather you than me. Oh my goodness! Yeah, I think that there's a time and place for the incredibly terse write once, read only code. I think Richard Campbell calls Perl read only, right? Once you've written it, you ain't never going to change it again. And there's a time and place for that, but most of the time, most of the apps that most people work on, they need to be, debuggable or at least readable, right?
Yes, absolutely. Yeah, the write once is a great way of describing that kind of code. Yeah, you understand it when you're writing it, and then after that, hopefully you understand it still.
Absolutely. Yeah, I'm a very big proponent of making code readable. I've got it right here, and the listeners can't see it, but it's in Code Complete 2, a book that I read every couple of years. And there's one bit that always leaps out at me, and that is, I'm not going to quote it directly, but essentially, the one thing we need to do as developers is make our code readable for other developers, because the other developer could be you tomorrow. It could be someone else on your team. If you can't read it, you can't debug it.
Yes, yeah. There's some quote about that saying if you write code, I'm not going to remember it exactly, but essentially, if you write the smartest code you know how, debugging is harder. Then you're not going to be smart enough to debug it. So yeah, I love that book too. Code Complete is a fantastic classic.
Absolutely. And with modern C# and, the just-in-time compiler and all that kind of stuff, it's constantly reevaluating and re-optimizing your code anyway. So
Yes.
You could spend loads of time ahead of time writing really complex, difficult to debug code. And then what's going to happen is at runtime, the jitter is going to step in and go, I'll make that better for you. Because there are hundreds of people, maybe thousands of people who, and I'm not going to say about you, but way smarter than I. Definitely way smart. These are like PhD people, right? And these are compiler design people. They know their stuff. I'm going to let them do their stuff, and I'll just write hello world. It's fine.
Yes, the tiered optimization is something I just dove into more than I have previously, just a couple of weeks ago. I knew it was there, but I never really played with it very deeply. But there's a great blog post by Stephen Tobe just recently on performance improvements in .NET 7, I believe, is his latest one, and he talks about using. There's this fantastic technique that he uses where they as a generic argument, they pass a value type that implements a certain interface. And by constraining it to that interface, what they're actually doing is forcing the compiler to create two different copies of the code, since it's a value type. And then because it's constrained to the interface, the jitter as it goes over that code, if it's called multiple times, is really able to optimize it extremely tightly. So it's just this fascinating little trick, that they were able to do. And I was looking into that more over the last couple of weeks. It's not the kind of thing I think I would have ever even thought of, but it's quite interesting.
Yeah, and the most fun part about that for me is we got all of that for free, right?
Yes.
And that just means that when you're able to migrate to .NET 7 or indeed .NET 8 if you need the long-term support, you get all of that out of the box for free. So technically, your apps could possibly run faster in the long term, or be more efficient, or use less resources, or all of these things could happen, and you get it for free. You don't have to pay for it, which is mad.
Yes, yeah, they're always working on updating the compiler, updating the tiered optimization in the just-in-time compiler, and of course the base class library as well. I love the optimization posts that they do, because every time I think, wow, that's amazing, well, I'm sure it's as good as it's going to get now. And then the next version of .NET comes out and it's like, wow, they did even more.
I often, not going to lie, I get about a quarter of the way through those optimization posts and go, this is just numbers now. I don't understand it. There's a bunch of stuff happening, and my code goes in and it comes out better. That's about as far as I get.
Just retarget the new framework and your code is faster.
Absolutely, that's it. Maybe they should put that as a TLDR at the top of every post. Change the TFM, recompile, and it's better. Fantastic. Thank you very much. Good night. Oh, gosh. So, okay. So we're going to talk a little bit about the comparers library. And there's lots of stuff to cover with this. And, for the listeners, I've said this loads of times, there's a bit of insider baseball talk. Before we do these interviews, we usually have a bit of a discussion about what we're going to talk about. And I've got loads of notes here. And, I hope we can get through them all. Because I feel like it's quite a detailed topic, which is good. I like this, right?
It's more than it seems, yes.
Okay, so let's talk about the comparers then. I do have a question much later on about, can I just, because comparers is for comparing things, right?
Yes, so my comparers library is geared around being able to define comparison or equality, which is like a subset of comparison, on your own object types. That's what it's designed to do. Or even other object types, I guess. It could be third party.
Okay. Right. So say I want to use the comparers library to test for equality of two objects. Can't I just use double equals?
So great question. And it really depends on what you want to do first. So, that if you have an object type, then double equals by default uses a reference equality. So you have an object instance that is really only equal to itself. And any other object instance, even if it has all the same properties and whatever, is going to be not equal to that because they're two different object instances. So you have a reference equality that's kind of built into to object types. And I actually prefer that. I use that as much as I can everywhere in my code. Coming from a C++ background, that was very odd for me to have this kind of reference equality, because in C++, references don't really exist. You've got shared pointers and things like that. But really, references are not widely adopted. It's not the natural way to program C++. So when I first started writing in C#, reference equality seemed very odd. But now I prefer it for everything. That's my default go-to. But that's not the only kind of equality that's useful. Value types, as the name implies with values, they use value equality. So you have like two different integers. Even if they're boxed, they are going to compare equal only if their values are equal. So these are the two kinds of equality that are built into .NET, or like the record types, actually. That's one I keep forgetting about, but record types use like structural equality by default. So they're equal if all of their properties or fields are equal. But sometimes it's really useful to extend this a little differently, or define equality or comparison using different rules. So one that's somewhat common is what I call ID equality or key equality. So you've got one property on this object, and what you really want to do is say if that property, this ID property or key property, is equal, then these two objects are equal. So you've got like this kind of key equality that's also pretty common. And a lot of people really like the structural equality. Again, coming from C++, I did at first, but now I tend more towards reference equality. But I understand, that desire for structural equality too. And that's, again, where all the properties are equal, then that thing is equal. But then sometimes you want structural equality that isn't quite all the properties. If you have metadata on your types, if you've got an E tag, an entity tag, or a last modified date, or something like that, well, you don't usually want to include that in equality. So really what you want is structural equality, except for these fields. And sometimes you want special values to be considered equal to other special values. So if you've got nullable integers, sometimes you want null being equal to -1, or like -1 and 0 being the same if those are your invalid values. Now, so there's all these different ways that you can compare things in different parts of your code. And I'm not saying that these are all a great idea, right? Because if you have 0 and -1 as invalid values, that's not ideal. But sometimes you have the code that you're given and you have to work within those boundaries.
Sure.
And sometimes it's nice to just define your own compares. The problem is defining your own compares is quite difficult. So that's why I wrote the compares library, is to really make that as easy as possible. So really sorry, that was a really long way to go about saying, first you have to decide what comparison even means to you. And I would even go so far as to say, a lot of people when they think about comparison or equality, they just, they assume that there is an equality or comparison definition that makes sense everywhere. So a lot of people say, well, I want reference equality everywhere, or I want structural comparison everywhere. But really, I've always found it useful to have, this part of the code wants to compare things this way, and this other part of the code wants to compare these same objects a different way. And that's actually really useful in some cases. So the compares library that I have allows defining different comparers. It's not just an object defining its own comparison. You can define a compare for other objects, and maybe this comparer object is used by this part of the code, and this other comparer using this other logic is used by this other kind of code. So that's the whole goal of the library, is to make that as easy as possible.
I see. So maybe in my head, I'm thinking and you can use comparers in whatever way you want to build, but if I'm working domain-driven design and I have a bounded context over here and my comparison over here, like you said, in that bounded context, my comparison is these three fields need to be equal and this one needs to not be equal, but in a different bounded context with the exact same perhaps models, it's a different set of, or maybe equality means something completely different in that other bounded context, right?
Yes, absolutely. And even things like object relational models, will have different assumptions around that. Entity framework, which most people use, kind of sidesteps it all by saying, well, if you have objects with the same key, they are actually the same object instance. And there's some name for that. I forget, reference identity or something like that they use to enforce that. So as long as you have one DB context and you're getting those entities out of that DB context, if it has the same key, then that's actually literally the same object instance. But not all ORMs follow that. Sometimes, I've actually seen some homegrown ORMs that use equality to mean, has anything changed? So it's literally like comparing all the fields except for the ID field to see if anything's changed. And there are other ones that use ID equality to say, well, if these reference the same, underlying row, then, if the keys are the same, then those are really the same row, even if the values are different. So there's many different ways to look at equality, even if you look at other ORMs, object relational models. Sometimes equality is used for things that can be a little surprising. And this just, with entity framework, for example, you are not supposed to override equality on your entities because entity framework uses reference equality and it depends on that. So if you want to compare them, you need a different compare, which is exactly what my library provides.
Yep. It's not in any way the same, but I remember when I first started doing C# development, it was really my first proper development. Before then, I'd done like homegrown stuff. I'd be like, oh, I've got a C++ book and I will learn the C++. Or before that, it was a little bit of assembler. So I was like, I will do the assembler stuff. Because when I was at college, so college over here in the UK, 16 to 18 years old, I did electronics and we had a Motorola 68K. And I mean, this isn't really that long ago, but the board was brilliant. It's called a Flight 68K. It's brilliant. Motorola 68K with about I want to say 2 megabytes of RAM and all that kind of stuff. You had to boot it. You had to drop out of Windows and boot into a DOS IDE to be able to program for it. It was brilliant. It used parallel port and everything. Amazing it was. But coming from that background, when I hit C# and I was like, yeah, but double equals, it means, is it equal? And, this object is not equal to that. And I used to fall over on that all the time when I was first starting until, like you said, until somebody said, no, those are references. Think of it similar to, but not the same as, references in C, because they're referencing like a memory address. I was like, oh, I get it now. But no, it wasn't written anywhere in the C# documentation, or at least the training stuff that I was going through, that a string is immutable and it is a value type and it lives over here, or is either one of these or one of those, and reference type and stuff like that. And I was like, oh well, I don't understand it. Why is this object not the same as that one? It should be the same. And then because it's not. So yeah, I think just comparison just means different things to different people. Regardless, right? Regardless of the domain you're working in and regardless of the language and the tools you're using.
Absolutely. Yes. It means different things to different people.
Absolutely. So is that where the idea came from then? You were just sitting there working with some objects one day and was like, oh, I wish I could just compare these things in this way without having to override equals and write a whole bunch of C# that does that equals.
I don't actually remember what I was working on when I started this project. But I know that I was implementing, I think it was, I don't remember if it was equality or comparison, less than, greater than. I don't remember which one it was, but I was doing it for a whole bunch of objects over and over again. And it was key based, I remember that. So it was, these objects are considered equal if, these 2 or 3 keys are considered equal or whatever. And I was just doing it over and over again. And I realized, okay, I'm writing way too much code to do this. Because what I want to do is say, I compare these two objects using this key. That's all I want to define. That's what I want to do. And nothing terribly complicated. But say an object doing it itself, right? If you're defining a natural comparison on that object, then you have to override object equals. You have to override object.getHashCode, which a lot of people forget. You have to implement IEquatable of t and implement the equals off of that. And all three of these are essentially using the same logic. And there's patterns you can do so that you can forward like the object equals to IEquatable equals. And that's fine. But you always end up with duplicate code in your getHashCode for your equals. And then if you're doing operator equals and operator not equals, that's even more boilerplate code that just forwards to the same code. So it just ended up being a lot of code with a fair number of pitfalls, especially between equals and getHashCode. And if you're doing comparison, you've got the compare off of IComparable of t, and then there's also IComparable without the t, which is also necessary in some cases, especially if these are objects that are going to be used by any user interface, because a lot of those use the non-generic interfaces. And at the end of the day, it was just, there's so much code just to get two objects to compare based on one field. It was just kind of ridiculous. So that's where the compares library was born, was I had to do that too many times. So I made it into a library, and now the compares library, just to give an example, you can say, I want a comparer builder. It uses like a builder API, Fluent API. I want a comparer builder that'll compare these types and then order by this key. And that's it. And it gives you a comparer that implements iEquality comparer of t and iComparer of t and the non-generic iEquality comparer and the non-generic iComparable. So it does all of that for you, and you don't have to mess around with a bunch of code.
Right. See, that's what I really like when someone takes, hey, this is a pain point for me, and I'll wrap it in a library, right? Because although I'm not always against don't repeat yourself, but if you're repeating yourself multiple times and there is no need for the code to be repeated, then totally wrap it in a library and use it elsewhere. But I'm also very wary of that advice, right? Because I'm very much a case of, if the code needs to be duplicated because maybe there's some nuance and you don't want to have 1,000 if statements to cover that nuance, right?
Yes, there's a few pitfalls you can go in that way too, right? If you're trying to make a method too generic and you end up with a long parameter list, or a parameter list with Booleans, for example, that's kind of like a flag. It's not necessarily bad code, but it's an indication that maybe this method is trying to do two different things if it takes a Boolean parameter.
Absolutely. On your point about overriding the hash code, I always remember my first programming job whenever I needed to do that. I would always be told, just put multiply by 13, that'll do. Multiply by 13 or modulo 13, that'll do. That's equality. And I'm like, but why? Why do you want me to do that? Well, just do it, because that's a short version. That'll do. And I feel like you could fall into pitfalls overriding that hash code, because you really need to think about what the properties are and maybe the order of precedence, right? Is the ID field more important or whatever? And so you really need to actually design that get hash code rather than just, that'll do. Number times number equals number, return.
Yes, you really do need to design it. And I don't know if that's the most common pitfall with implementing your own equality, but it's definitely a very common one. Because, so first thing, it's not obvious. I'm going to implement equality. I'm going to override equals. All right, I'm done. Or maybe implement equatable, and that's it. It's not obvious that there's another method called get hash code, something completely different that doesn't sound like it has anything to do with equality, that you actually have to keep in sync with that same equality logic, or else different algorithms will break. So these days, it's a lot better than it used to be. The IDE will warn you. And I believe both Visual Studio and ReSharper will say, hey, you did not implement get hash code. You got to do this. So the IDE is definitely better than it used to be, with those kind of warnings. But it doesn't really give you a lot to go on either, because I've seen get hash code implemented incorrectly as well. And combining the hashes is not entirely straightforward, although there's a new type. I don't know if it's in .NET 6 or 7. I think it's in .NET 6, maybe even earlier. There's a hash code type that's specifically for combining hash codes.
Cool.
So it's specifically like, use this to implement get hash code. That's the implicit assumption, I think, behind that type. And my comparers library actually does not use that yet. One reason is my comparers library targets all the way back to Net Standard 1.
Right.
So.
Right. Yeah, which doesn't have all of that lovely, wonderful stuff.
No, it doesn't. That's actually quite old code. I think Net Standard 1 might even support like Windows Phone. Like, it's that old.
Yeah, I think it does. I think it supports that. I think. Now, I'll look it up in a second. But before I look it up, I want to say it supports as early as .NET 3.5. .NET Framework, 3.5. Because 3.5 has compared to the rest of it, in my head, it has a very strange life cycle. Like its support goes into the 2030s. And all of the other versions around it have been dropped. But I wonder if that's because of like embedded stuff. And I mean, it doesn't really matter, right? Microsoft they can support things however they want, right?
I'm going to guess .NET 4.5.
Let's have a look.
3.5 added link and stuff. 4.5 added async and await, which was really a fairly major language change. So I think Net Standard.
You're absolutely correct.
Okay.
.NET Standard version 1 supports as early as .NET Framework 4.5. So yeah, you're right. As of today, as of me reading this, right?
Not that standard even really matters a whole lot anymore. We're moving into the one .NET world at this point.
Absolutely. We're finally reaching that point.
Yes.
Excellent. Okay. So I have in my notes that other languages have a thing called the spaceship operator. And I remember that was because when we first got chatting, we were actually discussing the spaceship operator. And I was like, I've never heard of this. This is amazing. I'm going to go look this up. And for the folks listening, a spaceship operator, if you imagine it typed into your IDE, it's a less than symbol, an equal symbol, and then a greater than symbol, because it looks like a spaceship.
Yes.
I love it. But C# doesn't have that at the moment.
No, it does not. I actually looked it up a few days ago when we were preparing for this talk, and apparently one of the language design meetings had a quote. If you go and search in the C# language repo, I just thought it was a great quote. So I was searching in there for spaceship operator to see if anybody was really even thinking about it. But there's this quote from early 2022 where in one of their meetings, one of the members said, it's not attributed, so I don't know who said it, but one of the members said, one of my goals for the language of C#, a future language version, is to have the spaceship operator. I don't care what it does.
I like that.
Yeah.
You just type it, it's fine.
Well, and then one of the discussions, somebody recommended that it be used as like a forwarding operator. So if you've got like an interface or something, then you can say, I want to implement this interface using, forward all calls for this interface to this contained object. which I would really love, actually. I would love some kind of forwarding syntax in C#.
I can see why they would have chosen the spaceship operator, because it's like beam them up, transfer them over here, and drop them down, right? Or am I thinking too literal about this?
Yeah, I love the spaceship. So for my compares library, the logo is actually like literally a spaceship, because it's kind of sort of, if you squint, it's kind of a way of implementing a spaceship operator. So it's implementing, not using.
Sure.
On the implementation side. But yeah, if you were to, so looking at the spaceship operator in other languages, like not as a forwarding operator, not as, I don't care what it does, but in like C++, and I think Perl even has it. I'm not experienced in Perl at all, but I believe Perl has it in C++, and I'm sure several other languages. So if you use the spaceship operator, what you're really doing is saying, let me know if this is less than, equal to, or greater than, hence the keyboard, the spaceship that it looks like. Let me know how this object compares to another object with one line of code. And we kind of have that today in C#, if you just, or .NET, if you just call compare to. Mm-hmm. So a dot compare to b gives you less than 0, 0, or positive than 0, which is usually what the spaceship operator does in these other languages. Now, the implementing the spaceship operator is where things get more interesting. So in some languages, like I was looking at this in C++ a bit ago. I am way out of date on C++, just to be clear. That was my first programming language, but these days, the language has gone so far beyond me. But I try to read some things. And their spaceship operator, if you implement it, then by default, it also implements all the other relational operators. So you can say, I'm going to define equality or comparison for my type based off of, I don't want to say an ID field because that's a bad example to use for comparison. You compare equality, or you compare identifiers by equality, not by like less than. That's not useful. But if you were comparing people by name or something like that, to sort people by their name, then that's the kind of thing where you could say, I'm defining comparison on my person to be based on their name. And that's like where the spaceship operator implementation can come in there.
Looking for a reliable and efficient data connectivity solution? Look no further than .Connect by DevArt. DevArt's cutting-edge products provide seamless integration with a wide range of databases, allowing you to streamline your workflow and increase productivity. Whether you're a developer or a business owner, .Connect has the tools you need to succeed. So why wait? Try .Connect today and experience the power of reliable data connectivity. Use promo code NETCOREPODCAST, that's NETCOREPODCAST, for a 10% discount. And head over to devart.com/.connect for more details. That's devart.com/DOTCONNECT, or check the show notes for link and details. So I guess then, in an ideal world, we don't really need a spaceship operator in C# because we've got compare to and we've got the comparers library, right? Or do we?
Well, so I've actually, I have a bit of an interesting history with several of my libraries that I've written. Then the C# language or the BCL itself eventually gets those same things. And then my library is no longer useful, which I am 100% on board with, because then I don't have to maintain it anymore. So there have been several libraries that's happened with, and even async.ex. If you look, there's a .NET Futures project, which is kind of, if I understand it right, I'm not sure on this, but if I understand it right, I think it's actually like BCL team members essentially like playing around with what future parts of the BCL may look like. And one of those things that they have in there is asynchronous coordination primitives, which is almost all what my async EX library is used for. So who knows, in another .NET version or two, maybe async EX is going to be no longer necessary. And maybe in a future .NET version, if we have a good spaceship operator implementation, most of my compares library wouldn't be necessary. And I don't mind that. I'm 100% on board with these ideas entering .NET proper, and then I don't have to maintain them anymore.
Yeah. It's also a sign of a really good idea as well, right? Because if the team adopt it, then clearly you were doing something right.
That's a nice way to think of it, yes.
Sorry.
I was just going to say, usually they adopt it without actually having seen mine.
Well, yeah, oh, well. And I was going to say that's why none of my code will ever end up in the .NET base class libraries, because it's not good.
I'm sure that's not true.
That's very kind of you to say. Okay. So yeah, we've talked about how the comparers library solves a certain problem, and that comparison doesn't mean the same thing to everyone. Mm-hmm. And we've discussed a little bit about the spaceship operator and how, if they bring the spaceship operator in, maybe comparers can perhaps be retired, or maybe it can just live as an alternate way to do things. Because, like we said earlier on, it's always good to have multiple tools in the toolbox, because two different screwdrivers will drive screws in. I mean, you are just applying rotational force to it, but a Phillips head screwdriver cannot work with a Torx head screw, right? So you need the different tools anyway, because there's always going to be some small difference or some semantic difference that you can do easier with one library than you can with another, right? So
yes,
long live comparers is what I say.
I'm sure it will continue to live, if only because I've taken one interesting difference in opinion from the BCL authors or the .NET team, and that's actually around how null is handled. Mm-hmm. So yes, we can talk more about that if we want.
Absolutely, let's do that.
Okay, all right.
Because I feel like null is, it's known as the $1 million mistake, but everything in memory has to be set to something, right? And I'm happy with null being a thing. I'm happy with it. A lot of people aren't, but I'm happy with it.
It's useful, yes. So if you look at the design of the .NET BCL, and especially around how equality and comparison works, it's not obvious at the beginning, I don't think, but it becomes pretty clear that null is treated as literally as no value. And that's not something that I realized when I started writing my comparers library. So, for example, one of the constraints around equals and get hash code is if you pass two equal objects into equals, then you pass both of those objects into get hash value, they have to have the same hash. That's a constraint. It's a requirement on how you implement get hash code. So the question is, when you pass two different things into equals, what is actually a value? And it comes down to this, kind of semantic thing. And I read the documentation as saying one thing, and the .NET team read the documentation as saying something else. So there's some interesting history here. So if you call dot equals and you pass null and null, that is actually allowed. It's right there in the documentation of equals that null has to be equal to null. And if you pass null into get hash code, so we're going to follow that rule of if we pass two things into equals, then if we pass them into get hash code, they have to have the same hash code. Mm-hmm. Well, if you pass null into get hash code, that's actually invalid. So it actually has undefined behavior. And the reason for this is I was seeing this as, well, if you pass two things into equals, then you should be able to pass them into get hash code. The .NET Core team was seeing it as, if you pass two values into equals, and you pass those values into get hash code, then they should be the same. But null is not a value. And I was saying, well, null kind of is a value because you can assign it to a variable, you can pass it as an argument, so it is a value, even though it kind of means missing value, right? So from the .NET team's perspective, equals, and you pass two nulls to it, is allowed, and they're always compared as equal. But if you pass null into get hash code, that's invalid. Now, some of the compares in the .NET BCL will return a value if you pass null into get hash code. It'll return like some value that it always returns for null. It's like hard-coded. Other compares in the .NET base class library will throw an exception. So that's kind of like this interesting edge case behavior of something that I didn't really pick up on until I was fairly well along. I'd already written my compares library, assuming that null was a perfectly valid value. And then when the .NET BCL was updated with all the nullable annotations, this can be null, this can't be null, when all of that happened a while ago, then my compares library started having a lot of trouble upgrading to nullable because I was allowing null into get hash code everywhere. And really the underlying implementation was very dependent on doing that. That's one of the interesting edge cases. And one of the digressions, I thought about it and I decided I'm going to stay allowing null. And it's not, so the .NET BCL, if you compare nulls, null is always less than everything else. With my compares library, you can say null is equal to something else if you want, or you can compare null as larger than everything else. So if you have like a sorted list, all your nulls end up at the end instead of beginning, that kind of thing. Sometimes it's just convenient to toss the nulls at the end or to compare them as equal to 0 if that's your invalid value or something like that. And the compares library allows that. I doubt if a future spaceship operator in C# would allow that because of the historical treatment of the .NET team as null is not a value. It can't really be compared to anything.
Right. See, that's really interesting. Like, part of me's thinking is that, I mean, we won't know, right? We're just waxing ideas here.
Right.
I think that's probably the wrong way to put that, but I wonder if that's a combination of everybody forgot at some point whilst implementing different comparers or parts of the BCL, or maybe that's one part has evolved whilst another part has stayed. I don't want to say stagnant, but I mean, this would have been early on in the .NET BCL's lifetime, yes. Right? So this would have been pre 1.0. But I wonder, with everyone working on it so rapidly, I wonder whether just a decision has gone one way and a different decision has gone a different way, and we just have to deal with this undefined behavior, like you say, for get hash code.
I have no idea on the history, just flat out say that. But I suspect that it comes from the old pre-generic world, so .NET 1.0. Before I ever used .NET, I don't think I even started using it until 3.5, somewhere in there. But long before I used .NET. Before generics were there, I think that the original idea around get hash code not accepting null was because they made a decision that your dictionary keys cannot be null. And I think that that's really the root of all this, because get hash code is mainly used by dictionary and other hash set kind of containers. And I think that that's where that's originally coming from, is they wrote a dictionary. They didn't want to deal with null keys. And so, to them that, if your key doesn't have a value, does it make sense that it's even in the dictionary? I can understand that.
Yeah.
Right. So they didn't support null keys. And then this whole idea of get hash code not supporting null kind of just grew out of that. That's my assumption, but I really don't know for sure.
Right, yeah, and usual standard disclaimer that we throw out for these episodes is that's just us two talking, and we don't know, right?
Right.
So we weren't there, we weren't part of that decision. A decision was made, and now we've all got to deal with it.
Yes, and who knows? At this point, if anybody would even remember, or if it was even written down. They were moving so fast back those days.
Totally.
Who even?
But
knows?
I mean, the reasoning behind your guess makes perfect sense, because if you think of a dictionary as a physical object, i.e. a dictionary for a language,
yes,
you're not going to have an entry that doesn't have the word exists but the definition. The word doesn't exist but the definition does. That doesn't make sense. You don't have a definition for a word that doesn't exist, right? So I totally get that. Whereas you can have a word without a definition. That makes sense. You can use a word without it having a defined meaning, but you can't have a defined meaning for a word that doesn't exist.
Yes.
I guess you can, because people use the term schadenfreude, but,
It's a great way of putting it. Yes, the physical dictionary.
Cool. Okay, so that was one of the things I was going to ask you about with the Comparers library. How does it deal with nullables? Is it just kind of the same? Is it just like you can, as your non-nullable type, so you can say, hey, when I pass you a nullable foo, it is equal to a nullable bar if both of them are null. Right? Is that kind of just how it works, or does it get really complex around that?
So you can make the logic as complex as you want. With the Comparers library, you can treat nulls specially. However, by default, it will do the .NET style comparison of nulls. They're less than everything else. They're only equal to each other. So because that's a very useful default behavior, but the Comparers library does allow you to override that. You have to pass a special parameter to whatever method you're using to say, well, actually, I want special null handling here. Because with the Comparers library, you would define a compare, say a key comparer. Okay, we're comparing people. You would say, I want a compare builder for people, dot order by, and then you would pass X. You would pass a lambda into that, just X goes to X dot name. Right. Well, most usage of that, people would be surprised if X was allowed to be null in that, even if they were comparing nulls. So by default, it does the null comparison logic before it even calls into that lambda. So the X is known not to be null. But you can also pass hey, I want special null handling here, and then you could say X goes to X is not equal to null, for example, or X is equal to null. If you want to compare, say, like nullable integers, like to go back to your example, if you want nullable integers, but you want all the nulls at the end of the list, you want to sort this list and have all the nulls at the end, you could create a key comparer that goes X goes to X equals null. And what that does is it really just compares true and false. And true is always considered greater than false. So if it's null, then they go to the end.
Right.
And you'd have to pass the special null comparison flag to say, hey, I actually want nulls in this lambda.
Right. Okay. So it's kind of built in that it's supposed to. Okay.
Yes. So it works just fine. But it also, I strive for like a reasonable default behavior. But if you want to do something fancy with nulls, you can opt into that.
So I can imagine writing tests for this whole thing, right? If you're allowing anything to be compared in any way possible, I can imagine there are about 1 million lines of tests for each thing that you could possibly set up, right?
There are not 1 million. I didn't actually count the lines of tests, but there are more than 1,500 tests currently.
Wow.
Yes. Now, a lot of those are tests that essentially test different kinds of comparers in the same scenarios. So they're kind of like templated tests. And it's been a while since I looked at that test code, but I use this really funky like XUnit style of here pass in all these different things, but I'm actually passing in like lambdas and things like that as my test data in order to. It's pretty complicated, the test code, but the end result is there's over 1,500 tests, and they test, as far as I know, every possible edge condition because there are many. There's just I have. This is by far, by the way, the most tests out of any of my open source libraries. Compares has more tests than anything else. And it didn't start out that way. It started out as, oh, I'm just going to implement this compares library and I'm going to do this and it's going to work. And I had some basic tests and that was it. And then people started using the library in unusual ways. And then I realized, oh, I'm not covering all my edge conditions. And so a few major versions ago, I think around compares version 4 or 5. It's currently on version 6, major version 6. And I had to go through all these endless edge conditions, just finding all kinds of stuff. And so that's when I got tons and tons of tests into this library to handle all this stuff and fixed all of the little tiny weird edge condition bugs. So to give an example, if you have an equality compare for integers, let's say, and compares supports non-generic interfaces as well, which again is used by a lot of user interface or like very generic kind of code. So it also implements equality compare without the T, without the generic argument. So what if somebody casts it to that interface and then creates a new object instance, has nothing to do with integers at all, creates a new object instance and passes it to the equals method on this equality compare that's designed to compare integers, right? A value type. What's even the most reasonable thing to do in that situation? It's crazy. Mm-hmm. But there are like occasional situations where things like that will happen, like usually deep in some library code that's using this as an equality compare. And so I had to decide how are we going to handle this, and all these different kinds of edge cases. And I found some interesting framework behavior where they handle the edge cases differently in different compares. Like I mentioned, the get hashcode null. If you do a string compare.ordinal.get hashcode null, it will throw. But if you call equality compare of string.default and call get hashcode on that, which is really the same compare, right? The default compare for strings is an ordinal comparison. But if you call get hashcode on the equality compare.default, it does not throw. So right. So there's some fun edge cases around nulls, and what if you have a compare for a value type and somebody passes objects to it? What if they're reference equatable? Should it return true or should it throw an exception? So the compares library has now, as of version 4 or 5 or whatever, we're currently in 6. As of now, the compares library has consistent rules for how it handles all these weird edge cases, so that the behavior is very predictable. And I love that. Although it did require, again, this library has more major revisions, I think, than any other library I've written. So it's on version 6. That means it had 5 backwards incompatible breaking changes in the API, some of which were necessary to fix some of these edge cases. It's just ended up being a lot more complex than I thought it would be going into it. You wouldn't think it would really be that complicated.
Yeah. Like we started this conversation, and we started the behind the scenes conversation, and I was like, okay, right. Quite literally, why would I use this versus double equals? And you're absolutely right. It all depends on what the comparison means and about those edge cases, because those edge cases define what your comparison is. and it then perhaps allows the developers, the designers, the implementers of the code or whatever, the chance to actually sit and think, right, what does this actually mean? Maybe
Yes.
I have to go back to the domain expert. What does it mean if this set of circumstances leads to this value? Rather than it being something that is a bug that's caught in live, you can then, because you're using comparers, you could wrap it in a unit test and say, right, okay, everyone, look, here's my unit test. What am I asserting here? What should be correct behavior? And then you get the sign off, and then that becomes a regression test. And then somebody passes in a null, or somebody passes in the word Jeff, and it's supposed to pass, but it fails. Well, guess what? You've now got your regression test you can fall back on. I like it. It's a lot better than just using double equals. Excellent. Okay. So talking about comparers and perhaps about yourself as well, are there any links that you would suggest people check out to learn more about comparers and the other libraries you've done? And maybe, different people do different things. You mentioned earlier on you were doing a YouTube video. So this is essentially a chance for you to, let's do the promo stuff and talk about me, and totally please do that. And what I'll do for the people listening is whatever you mention, it could be about you, it can be about, hey, I want to learn more about comparison in .NET, whatever. Whatever it is, I'll get a bunch of links and I'll throw them into the show notes. So whatever you're about to say now, this part of the transcription will be full of those blue underlined words. Go ahead and click it.
Okay, well, obviously the comparers library itself. So I'm Stephen Cleary on GitHub with a PH. It's Stephen with a PH. Let's see. So I've got a blog at stephencleary.com. I actually have not written anything on comparison yet. I've been planning to write this forever. I've got all the notes and everything all written up, but it's such a huge topic. I can go on and on and on about comparison and all the different things, all the different ways it can be done and the different ways you can implement it. And trying to get that into a blog post that's also useful is surprisingly difficult.
Yes.
And yes. So it's yeah. So I don't actually have at the point of this recording, I don't have any blog posts up on that yet. Maybe I will by the time this gets published. We'll see.
I wonder if, and this may make more work for you, I'm not holding you to this at all, perhaps a book? If a blog post isn't going to work?
Ooh, a whole book just on comparison? That seems like real overkill there.
Like I say, I'm not trying to make extra work for you, but maybe, I don't know.
I'm sure you could. To be honest, if you get much into comparison, there's some good articles online, and I don't know any of the specific ones off the top of my head, but there's a difference between mathematically equality and equivalence. And some of that plays into some of our comparison when we start looking at what do we want equality to mean. So there's equality versus equivalence in mathematics, and then in like .NET we have this additional concept of identity. So like reference equality. So you've got equality and equivalence and identity, and really most of the time what we're doing is equivalence, mathematically speaking. Mm-hmm. But then there's all kinds of there's endless rabbit holes you can go down. Like, what exactly is a partial sort, and as opposed to a total sort, and which things in the .NET actually assume a total sort and which ones don't. I think C++ is better defined there. That they have the notion of a whatever it is, the strict weak ordering, which you have to wrap your head around, sure, but it's very specific. .NET is a little bit more hand wavy. Say, well, we're going to compare things, whatever that means. Sometimes it doesn't make sense to do like a less than or comparison. Sometimes you can only define equality. And the comparison library supports that. But anyway, there's just so many rabbit holes you can go down with that. And it's not really something I understand completely. Every time I have to look up, okay, what is a partial ordering again? What's a strict weak ordering? I never remember. So, yeah, it's I don't know if I'm really the right person to write that. If it was a book, I guess.
Okay, well, like I said, I wasn't trying to make any extra work for you, but I was thinking it's bigger than a blog post. Maybe a series of videos. I don't know. Like I said, I'm not trying to make work for you. But there you go. Excellent. Okay. Yeah. Have you any other links? Maybe people can reach out to you on Twitter if you're on there or something. Or
Oh yes, I'm on Twitter sometimes. I tend to treat it as a publish only platform because it is it can be a little toxic. So but you can reach out to me on Twitter. I will see it sooner or later. I'm at a Steve Cleary.
Cool.
So that's my Twitter handle. I have a YouTube channel, which I try to write. I try to do it once a week or so, although it's been quite a while since I've done it, where I code whatever, some open source stuff. And we'll see if that continues. I don't know. It's not something I'm like, I've been very consistent on so far. But I've got a YouTube channel. I don't know, Cleary Coding? Or Clearly Coding? I don't remember. It's something like that. I'll put a link to it on my blog because I don't think there's even a link there now.
Yeah, and I'll get a link to it in the show notes. So if you're interested in finding out more about Stephen, click all of those links. And I would say give the Comparers library a shot because it is oh my goodness, it's so good.
Like, I hope it makes your life better.
It certainly did for me. That was something I did a few weeks ago. Was I brought it into a piece of code for a client, and I was like, okay, right, see all these hundreds of equality classes you're writing, yeah, right, NuGet sorted. Right, let's get on with this.
Nice.
Because I mean, at the end of the day, we're not getting paid by the line of code. We're getting paid for implementing features. So let's implement the feature faster, right?
That is the goal.
Well, thank you very much, Stephen, for being on the show. I really appreciate it. And there's loads of stuff that I've definitely picked up on, not just the corner cases in .NET, but like the fact that equality is different to different people. I had never, or rather not equality, I think comparison is the better phrase to use there. Comparison of two things in memory is different to different people. It will mean different things to different people.
Yes.
And having all of those. Sorry.
I was just going to say, even different parts of the code. Yeah. The same person writing two different parts of the code. And sometimes it's really nice to have two different meanings of comparison.
Absolutely. And I really liked this idea of having multiple different tools in the toolbox that maybe a library is already partially supported by the framework or whatever that you're using, but maybe the library does things that the framework doesn't. Keep them both around because there'll be something in both that you will use. You'll be like, it's the same argument with like Newtonsoft.json and system.text.json, right?
Yes.
One is heavy duty, like it's the comparers of JSON, right? Right? It does all the things really well. And the other one, it does them quite well. But there are some edge cases that don't work. That's your double equals in this instance, in this metaphor. That's your double equals. That's system.text.json. Newtonsoft.json is the comparers of JSON libraries, is how I'll put it.
It's a good comparison.
And again, and that may mean different things to different people. But anyway, I'm going to call it quits on this one just because I'm going to end up running out of things to say. But like I said, Stephen, thank you ever so much. I've really appreciated it, and I'm sure the listeners will too.
Well, thank you for having me, Jamie.
You're very welcome. That was my interview with Stephen Cleary. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave a rating or review in your podcatcher of choice. Head on over to .netcore.show/review for ways to do that. Or reach out via our contact page at .netcore.show/contact. And if a friend of yours or a colleague of yours has sent you this episode, head on over to .netcore.show/follow for ways to keep up with the show. And obviously come back next time for more .NET goodness. I'll see you again real soon. See you later, folks. .NET Core Podcast is a production of RJJ Software Limited.